John and I had a conversation where we're discussing the security aspects and security problems that we've got around the world on one hand side, and the everyday life of a programmer on the second hand side. And out of that discussion sprang an idea how we could use good habits from other parts of system development, like domain-driven design in particular, and have them address the security vulnerabilities that actually occur in code on the other hand side. And from that discussion on application security on one hand side and domain-driven design on the other hand, sprang forth an idea about some kind of domain-driven security as a mindset for programmers to naturally create a style of programming that will not mitigate, but just avoid SQL injection, other injection flows, cross-site scripting, and similar stuff. So we had a look at the top 10 OWASP list from 2007 and found SQL injection cross-site scripting and injection flows on top. And now we had a look at the new list, 2010, 3 years later, and what have we got on top? Cross-site scripting, as injection flows and cross-site scripting. So if you haven't fixed a bug for 3 years, you won't probably fix it at all. And if we still have the same security problems, the same vulnerabilities after 3 years, that is a little bit of a humbling experience. So this says something that we have to be better at finding ways for security experts and developers to cooperate and find practical means that work in the everyday life of programmers to move this forward, so that we will not have those two as the top two in 2013, at least. But I volunteered to do some kind of demo or die presentation on this issue, and I will leave it up to you whether I demoed or whether I should die. So let's get on to touching some code. I'm going to start with injection flows, and I'm going to talk about SQL injection in particular, but only as an example. Of course, the same things apply for XPath, creating file paths, LDAP queries, etc., etc. So quick poll here. How many of you are like developers or close to developers, having touching code or viewing code as part of your everyday life? Excellent, few of you. Then you'll know what I'm talking about. I'll start with assuming that you know what SQL injection is all about. Here we've got a vulnerable application, which is kind of a content management system where you can log in as the administrator, John. And unfortunately, then you have got access to, for example, some admin stuff there at the bottom left. But unfortunately, you can also log in using the generic login string, 1 = 1, and logged in as John. So what's the cause of this? Obviously, it's somewhere on the hood we have got some code that verifies a user, which is called by, let's see, the client side presentation tier. So we get the username and passed over to the verify user, which under the hood will compile a big string pass it to a database for validation. And of course, here is where maliciously designed data can change the structure of the SQL query. So let's make a technical attempt to say that, okay, the problem here is that we can log in using this design string. So let's start with having a look at this and trying to solve the in-data validation problem. Those strings should not be allowed. Okay, one obvious way to do this is, of course, to get the username string and check whether it matches some regular expression. For example, we allow short username style of names, like A to Z, at least one of them, and if it matches, then we're allowed to verify the user. Well, good news is that we sign out and make sure we haven't made a fool out of ourselves. We can still log in as John. And what about their text string? So we've solved the problem. Great. Okay, now taking a technical attempt, and we'll see that this will actually lead to a dead end after a while. But we don't want the validation on the outside. Of course, we want to make it available for all callers of verify user. So we'll put it on the inside of verify user instead. If it is not the case that the username matches A to Z, then we just return false. This is the way a lot of code goes. Of course, now this clause we want to make available for more parts of the code. For example, we got create user down here that would definitely benefit from the same validation. So let's extract this. As a valid username method, now available for the rest of the code in the class, but to make it really useful, we'll make it public, so any code can use it, and static. So now it's available for anyone. They just have to know that within user action there is a valid username method to call. Will they know that? Thumbs up or thumbs down? No, because we must make it available so anyone can find it. So therefore, let's refactor this a little bit more and put it somewhere where everybody will find it. Let's move it to the util library, to the util class. And we got the util class down here. There we got it. Now everyone will find it. The problem is it doesn't work this way. I've tried, I've seen this over and over again. And this util class often end up like something like 200 or 300 methods. At one occasion, I had a 300 method util class, which, for example, did validation of, there was a method that validated that a certain string was a properly formatted date. The problem was that there were 5 methods doing the same thing. And the real bad part was they were actually subtly inconsistent with each other. So how did this mess come to be? Well, no one can find them there. We have to, now we're relying on some technical issue, but we have to put this method straight into the path of the programmer, so they will find it in a natural way. So this obviously did not work. So let's roll back this and make a new attempt. I said let's roll back this and make a new attempt. So now I'm going to steal a hair from the dog domain-driven design and the main thought is we should focus on the domain and try to understand the problem and modeling that understanding in a very logically consistent way and make that model explicit. And I'm not talking about a model like a graphical model. I'm talking about a strict logical model that would then reuse in the source code, in the database, in the graphical user interface. So let's make a domain-driven design attempt. So the key question from a domain-driven design perspective here is, okay, we are missing something. What are we missing? We are able to use a bad username. What's the concept that is not made explicit enough? So let's have a look at the user action again. And it becomes painfully obvious that we're talking about usernames. We're talking about usernames and properties of username. This is a good username, this is a bad username. But nowhere in the code does it say username. We haven't made an explicit representation of that. So let's make one. Instead of saying that the verified user can take any old string as an argument, we want to restrict it to say we only want to have proper usernames. So what's a username? Well, a username is an object that contains a string, the name, and can be constructed. And now we clarified the interface of the method. On the inside of the method, we can, of course, work with the ordinary string, the name, which is the username dot name. Okay, having come this far, we actually have something that compiles, which is a good thing. And now the business side is made consistent in some way. It talks about usernames. Now we'll see what that does to the client side. Let's open up the sign-in again and see that now we are encouraged to not send in any string into verify user. We have to actually say that this is not any old string, it's a username. And we can do that. We've got a constructor. And everything is fine. So let's see what have we gained. We can still log in as John. I love having automated tests. To manually do the same test over and over again does not really help you. Let's see what happens with a text string. Oh, we can still log in. Yeah, obviously. We haven't done anything yet. We haven't changed anything yet. What we have done is, yes, we have refactored to make the code talk more explicit about the problem at hand. But now we've gotten to a state where we actually can talk about the properties of the username. We can say that the username is too liberal. It shouldn't allow the text string to be constructed as a valid username. And of course, we can document that using a test case. So a username should accept short usernames, and we can run this test and see if it does so. Yep, it does. We're in good shape. However, we should not allow the text string as a valid username. So for this test, we expect it to fail with legal argument exception.